Good evening all. Am I audible? Good evening everyone. Am I audible? Yeah, okay. Selva Kumar, good evening. Venkateshwaran, good evening. Let us wait for a few minutes for the remaining members, okay? So, Rajeshwari Devi, good evening. So, yesterday I go through the assignments. Only I think 68 people were submitted their assignments. What about the remaining members? And when you post your assignment, now we are in IOT class, not Python class. Python and data science have already over. So when you post your assignments, mention using hashtag IOT, don't mention Python. So during third assignment and fourth assignment, don't forget to add hashtag IOT, don't add Python please. Vasanta, good evening. Okay, so today is your 15th day. Today you will get your third assignment, right? So those who are not submitting the second assignment, please try to submit as soon as possible. Okay, shall we start the class? So today's topic is IoT based heartbeat monitoring system using ESP8266. So in this project we are going to build an IoT based monitoring system using NodeMCU ESP8266 that will able to measure the current heartbeats and publish the data to the cloud platform. So hence the data can be accessed from anywhere around the globe. This project helps to provide high quality support to patients and make things easier for medical staff. So normal people can also use this as a part of their life to monitor their heart health. So in this session only we are going to see theory part, like I am going to explain the code and I will show you how the output will be. At the end of the session I will give you an assignment. Gokul Prasanna, good evening. Hari Haran, good evening. Okay. So let's get into the topic. So what is pulse sensor? So it is an analog device that is used to measure the pulses or heartbeat of the human body. It monitors the change of blood in the blood vessels by emitting and sensing the light. So it has three pins. One is ground pin, VCC pin and signal pin. So the VCC pin, this pin is used to supply power to the sensor to make it work. It is typically connected to the 3.3 volt pin on the node MCU board. Its voltage lies between 3.3 volt to 5 volt. So you can give 3.3 volt or 5 volt to your ESP8266 microcontroller. So coming to ground pin, this pin is used to connect the sensor and the ground of the node MCU board. And coming to signal pin, this pin is used to transmit the pulse rate data in analog form to the node MCU board. So it consists of one LED and noise elimination circuitry also. So then OLED display. Using this display we are going to display our heartbeat per second. So organic light emitting diode, which is OLED display, are used to display the output data. So they are extremely light, paper thin, theoretically flexible and produce a brighter, crisper image. So it has 4 pin, one is VCC, one is ground and another 2 is serial clock and serial data. Yeah, it work on I2C. So coming to VCC pin, this pin is used to supply the voltage to the OLED display to turn on the display. The voltage range of OLEDs lies from 3.3 volt to 6 volt. So you can give 3.3 volt or 5 volt. And coming to ground pin, this pin is used to connect the display to the ground of the node MCU board. And then data pin. So this pin is used for data transmission in I2C communication. So it is typically connected to the D2 pin on the ESP8266. So D2 pin is serial data pin and D1 pin is serial clock pin, right? So coming to serial clock pin, this pin is used for clock signals in I2C communication. It is typically connected to the D1 pin on the ESP8266 microcontroller. So then ThinkSpeak setup. So before writing the code, what we have to do is that we have to set up the ThinkSpeak. So here what we are going to do is that we are going to monitor the pulse rate using that sensor, and we are going to display that output in OLED display, and also we are going to upload the data in the ThinkSpeak cloud. So this is what we are going to do. First, we have already saw how to log into the ThinkSpeak, how to use ThinkSpeak server, right? So first of all, create a new account on ThinkSpeak website. So then log in using your email ID and everything. So create a new channel, and I think you already know that how to create a new channel, how to create a field name, and how to get your API keys and give the name to the field in the channel. Use it for data monitoring. You can give whatever you want, and inside the channel go to the API keys because we are going to use that API key now. So this is how you set your ThinkSpeak cloud, and now let's get into the code. Okay. So here first start with libraries as usual. So first I am going to give include. So include, I am going to give SPI library dot h. So this line includes the SPI library, which provides functions for serial peripheral interface communication. So it is used for communication between microcontrollers and peripheral devices. For that purpose we are including SPI library here. Then we have to include wire library, wire.h. So this line includes the wire library which enables I2C, inter-integrated circuit communication. So I2C is a multi-master, multi-slave serial communication protocol, right? So commonly used to connect microcontrollers and peripheral devices. Then we have to include Adafruit libraries, which is for OLED display. So before that you have to zip your libraries into your Arduino IDE. So if you go to Google and search for Adafruit, the module name, OLED module name is SSD1306. If you search for this or Adafruit libraries overall, you can get your libraries from Google and you can zip that folder and you can include that in your Arduino IDE. So here include Adafruit, model name is SSD1306.h, and then include again Adafruit GFX.h, and then library for Wi-Fi, ESP Wi-Fi. So this two library. So this line includes the Adafruit SSD1306 and Adafruit DFX libraries. So this library provides functions for controlling that OLED displays and graphic rendering respectively. So it is a popular OLED display controller chip. This one is. So now we have to include Wi-Fi libraries for ESP8266 Wi-Fi.h. So this line includes ESP8266 Wi-Fi library which enables Wi-Fi connectivity on the ESP8266 microcontroller. So it provides functions for connecting to Wi-Fi networks, which configuring network settings and performing network related tasks, everything and all. So then we are using ThinkSpeak Cloud, right? So for that we have to include ThinkSpeak libraries also. So ThinkSpeak.h. So these are all about the libraries. So this line includes the ThinkSpeak library which allows communication with the ThinkSpeak IoT platform. So it is a cloud-based IoT platform that provides storage and visualizations of data from connected devices. This is all about the libraries. Then we can move to Adafruit SSD1306 display, and inside I am going to give 128, 64, and wire. So in before previous class we have used 16x2 LCD, right? So that why we have mentioned that slave address 16 column and 2 rows. So here we are using 128x64. So that's why I gave 128 and 64 inside as a argument. So this line creates an object named display of type Adafruit SSD1306. So the constructor is called with parameters which is 128 and 64 with respect the width and height of the OLED display in pixels. So the and wire parameter indicates that the display will use the wire library for communication. For that's why we gave 128, 68, 64 and wire inside as a passed inside as a argument. So now Wi-Fi client. So this line creates an object named client of type Wi-Fi client. It is used to establish a client connection to a remote server over a Wi-Fi network. So the object provides methods for sending and receiving data using the TCP or IP protocol. So now what we are going to do is that we are going to mention pin number We are going to initialize pin number. For that we have to create variable. First I am going to create constant. Data type is integer sensor pin. Here we are using analog sensor, right? So that's why we have to give a naught, and then another variable integer sensor value. We have to store the data in some variable. For that I have created sensor value. So this line defines a constant integer variable named sensor pin and an integer variable named sensor value. So the sensor pin is set to A0, which refers to analog pin 0 on the microcontroller. So the sensor value variable will be used to store the analog reading from the sensor connected to pin number A0. So now I am going to create another variable called integer count. I am going to initialize this as 0, and then unsigned long start time. This is also I am going to initialize as 0. Then integer heart rate. This is also I am going to initialize as 0. Then boolean counter, which is equal to I am going to give us false. So these line declare and initialize various variable used in the code. So count is an integer variable initialized to 0. Start time is an unsigned long variable initialized to 0, and heart rate is an integer variable which is initialized to 0, and counted is a boolean variable which is initialized to false. So these variables will be used for heart rate calculations and tracking. For that purpose we have created these 4 variables. So now then we need to initialize channel number and API key. So here I am going to give long my channel number. So here you have to give your channel number. I am going to leave it blank. So here I give a command like replace this with your channel number. Okay. So if you are setting your ThinkSpeak, in the sense you will get your channel number and API key, everything under. So you have to replace this space with your channel number, and then I am going to create another constant character my write API key. So here you have to give your API key. So here I am going to give like enter your API key here. So you have to enter your API key here. So here you have to replace with your channel number, and here you have to replace with your write API key. So now let's move to void setup function. So inside void setup function I am going to initialize the OLED display first. So display dot begin, inside the bracket I am going to SSD 1306 underscore switch CA PVCC command 0 cross 3C, which is your address. So this begin function is called on the display object, and it takes 2 parameters. One is SSD 1306 switch CAPV double C is a constant that configures the OLED display's internal charge pump, and 0 cross 3C is the I2C address of the display. I think I already told you how to find out your slave address of your I2C LCD, right? So after installing the library, if you go to the example programs, you will get some example program. Click any one of this, then you will get your address, or you can go to Google and type just how to find out my particular LCD's name. slave address. You can get the sample code, copy that code and paste it in Arduino IDE. You will get your slave address on the serial monitor. So you can find it out either that way or this way. So then we are going to initialize the pin. So using pin mode function, I am going to give which is D8 as output pin. So this line sets the D8 as output pin and setting D8 as an output pin. Then as usual we have to give serial.begin. Inside I am going to give 115200 as baud rate. So then display dot clear display. So this line clears the OLED display. The clear display function is called on the display object to clear any previous content displayed on the OLED screen. And then we have to give Wi-Fi dot begin. Inside I am going to give my password and SSID. So this I am going to give. Here you have to give your SSID. I am just going to give like SSID and comma. Here you have to give password. So don't forget that. Replace this with your SSID and password. Here I just gave SSID password for example. Here you have to replace this with your actual SSID and actual password. So this line initiates the Wi-Fi connection to the network with the SSID which is your Wi-Fi network name and the corresponding password. So the Wi-Fi begin function is called with the appropriate SSID and password parameters to establish a connection. Then while loop for Wi-Fi connection checking. So while Wi-Fi dot status equal to WL connected. So this block of code waits for the Wi-Fi connection to be established. So it repeatedly checks the status of the Wi-Fi connection. So the status dots are printed to the serial monitor using serial print. So then serial.println blank, I am going to leave it blank. Serial.println, here I am going to give a message like node MCU is connected. And again, then now we have to print the IP address of the serial monitor. So serial.println Wi-Fi dot local IP. Using this we can print our IP address on the serial monitor, right? So then ThinkSpeak dot begin. So inside I am going to give like client as a parameter. So this line initializes the ThinkSpeak library with the client object. It prepares the library to communicate with the ThinkSpeak IoT platform using the provided client for the network connection. So that's it. Now we can move for void loop function. So inside void loop function I am going to give start time which is equal to millisecond This line assigns the current value of the system times in millisecond, which is written by the millisecond function, to the start time variable. So this value is used to track the start time of a specific section of the code. Then another while loop. Now I am going to give another while loop for while. Inside I am going to give millisecond, which is lesser than start time plus 20,000. So this line starts a while loop that continuous execution until the system time exceeds the start time value plus 20,000 milliseconds, which is 20 seconds. So this creates a 20-second interval for the code block to run. So inside while loop, now I am going to read the sensor value and store it in a variable called sensor value. We have already created this. So sensor value, which is equal to, we are using analog pin. So using analog read function, I am going to read this sensor pin. Then I am going to give a delay of, let's give just 50 milliseconds. So now I am going to make a if condition. So if condition, first I am going to give like sensor value, which is greater than or equal to 590, just any threshold value you can give. Here I am giving just 590, and sensor value, which is lesser than or equal to like 680, and again and symbol, and we are going to check false if this condition is true in the sense. So this line checks if the sensor value falls within a specific range, which is 590 to 680, and if counted is false, these conditions if true in the sense, this condition check if the sensor reading corresponds to a heart rate pulse and if it has not been counted previously or not. So inside I am going to increment the count variable. So increment the count variable. Now I am going to give digital write off D8, making height of this is nothing but LED, and again a delay of like 10 milliseconds. Digital write off D8 becomes low. So and also I am going to set counter to true to indicate that a pulse has been counted. So counter, which is I am going to make this as true now. So now I am going to make else if condition, which is for sensor value, which is lesser than 590 in the sense. So here I am going to make counter as again false, and I am going to make my LED is D8 the bit, right? So D8 comma, I am going to make this as low. So this line checks if the sensor value is below the lower threshold of 590. If so, it means that the sensor reading does not correspond to the pulse. So now I am going to print the pulse on the serial monitor. For that, using serial print, I am going to print that pulse. Serial.println, here I am going to print that count. So these lines print the current pulse count to the serial monitor. It provides feedback on the number of pulses which is detected within the 20-second interval. So now let's do a small calculation. Okay, heart rate is equal to count of 3. So this line calculates the heart rate by multiplying the pulse count by 3. So it assumes that each pulse corresponds to 3 beats per minute. So the result is stored in the heart rate variable. So now let's print the heart rate in BPM. So using serial.println, first I am going to leave this blank. Serial.print, here I am going to print BPM. It is equal to again serial.println HEART heart rate. So I am going to print that heart rate. Serial.println, again I am going to leave it blank. So this line prints the heart rate in BPM to the serial monitor, providing feedback on the calculated heart rate. So now I am going to make count as 0. So this line resets the count variable to 0, which is preparing it for the next interval of pulse counting. So now the same thing we need to print the same in OLED, right? So here OLED printing. So display dot, first I am going to clear the display. So this line clears the OLED display. It prepares the display to show new content by clearing any previous text or graphics, whatever. So then display dot set text color. So let's give white. You can give color white. So this line set the text color for the display to white. So this color will be used for the text displayed on the OLED screen. So now I am going to set the cursor. So set cursor, I am going to give 0th row, 0th column. So this line set the cursor position on the display to the coordinate, which is 0th row, 0th column. So it determines the starting position for the text to be printed. So now we can give size also. So display dot set text size of, I am going to just give 2. So this line set the text size to 2, indicating a larger font size for the displaying text. So now I am going to print the heart rate. So display dot println. So here I am going to print the heart rate. So this line prints the string heart rate to the OLED display, which is starting from the current cursor position. So the println function is used to print the text and move the cursor to the next line. So for that again we have to set the cursor, right? So set cursor. Inside I am going to log 0th column and 28th row. So this line sets the cursor position to the coordinates, which is 0th column, 28th row. So it determines the position for the next text to be printed. So again I am going to give display dot. So here we are going to print the BPM. So BPM, which is equal to, I am going to print. So again display dot print heart rate. So these line print the text BPM followed by the value of the heart rate variable to the OLED display. So the print function is used to display the text and the variable value without moving the cursor to the next line. So now display dot display. So this line updates the OLED display to show the newly printed text and the graphics. So it makes the content visible on the display, and at last we need to send the data to the ThinkSpeak, right? So ThinkSpeak dot write field. So inside I am going to give my channel number, heart rate and my API key. So first my channel number, don't forget to replace this with your actual channel number. Here we are creating only one field, so I gave 1 here. So now we have to send that heart rate also. So now my write API key. So don't forget to change this to your actual API key also. So this line sends the data to the ThinkSpeak channel specified by my channel number. So it writes the value of the heart rate variable to field 1 of the channel. We have created only one field, right? So the my write API key is used for authentication, which is providing access to write data to the channel. So you have to note down that write API key and you have to paste it in the code. So this line enables the recording and visualization of heart rate data on the ThinkSpeak IOT platform. So this is all about our code. So let us verify this. Make sure that you have connected the correct board and port. Here I didn't connect any board and port here, so it doesn't show the port. So Adafruit I2C device. So here there is some issues with my libraries actually. Okay, it's not a big deal. So these are the 5 libraries actually we have to use this in our code. So when you have downloaded it, if you throw some error in the sense, you can just download the libraries from another website. So this is all about our code. So if you upload this code into your microcontroller, in the sense your output will be look like this. So this is the connection actually. This is your OLED display, this is your LED, and this is your ESP8266 module, and here this is your pulse sensor. So the power pin has to be connected with the 3.3 volt of your ESP8266. Similarly your ground pin, and your output pin, which is A0 pin, has to be connected with output pin here ESP8266 A0. And coming to LED, here D6, actually we have taken D8, right? So D8, and the negative pin has to be connected with ground of your ESP8266. And coming to OLED pin now, the power and ground pin has to be connected with accordingly 3.3 volt and ground, and the clock pin has to be connected with D1, and data pin has to be connected with D2. This is all about your connection. So after uploading your code, your output will be look like this. First it will print the heart rate, and then it will print your BPM value. Then we move to the ThinkSpeak cloud, in the sense your output will be look like this. You will get your output like heart rate monitor. You have only created one field, right? So here you will get your channel ID, author, access is public, and you will get your API key, and this is your output. Your output must be look like this. So this is all about today's session. Do you guys have any doubt? In the sense, you can ask me. Is it clear, everyone? Do you have any doubt regarding this? Is it clear? So the third assignment will be same one. You have to rewrite the code I have explained before. Try to rewrite the code and verify it. If you have hardware with you, in the sense, you can interface and take a screenshot of it and post it in the group. Don't forget to copy that link and paste it in the Google form also. I will provide you the Google form after 2 days. Today is Tuesday, right? So Friday you will get your Google form. Before that, go and submit your assignments in the LinkedIn or Facebook community. So is it clear, everyone? So if it is clear in the sense, please drop S in the chat box or send thumbs up emoji in the chat box, please. So if you guys are clear in the sense, let us wind it up from here. So let's catch up at tomorrow's class with another topic. So thank you all. Have a great day.